So we'll finish by talking about the metabolism of branched-chain amino acids, and this includes isoleucine, leucine, and valine. So branched-chain amino acids make up about 25% of the amino acid pool, and they provide a primary energy source for skeletal muscle. In addition, they also provide available substrate to replenish TCA cycle intermediates in the liver. So the metabolism of our branched-chain amino acids, and again, those are leucine, valine, and isoleucine, is summarized here. Their initial step in metabolism, like all amino acids, is the transamination to a keto acid. And again, this allows for the removal of the nitrogen group. From here, the keto acids undergo an oxidative decarboxylation by a multi-subunit enzyme that is similar to the pyruvate dehydrogenase complex. This enzyme is generally termed the branched-chain keto acid decarboxylase, and similar to the pyruvate dehydrogenase, the enzyme requires thiamine as a cofactor. From here, the resulting carbon skeletons can be rearranged and will enter the TCA cycle. So what I want you to take home from branched-chain amino acid metabolism is twofold. First, it requires these two processes, transamination and oxidative decarboxylation. Our transamination step, like all transaminations, requires peroxidyl phosphate, and this oxidative decarboxylation requires thiamine. So why we're focusing on this specific amino acid metabolism is for the clinical relevance. So deficiencies in metabolism of branched-chain amino acids can result in the diagnosis of maple syrup urine disease. So again, this is due to deficient oxidative decarboxylation of the metabolites of leucine, isoleucine, or valine. The incidence is about 1 in 100,000, so this is even rare among inborn errors of metabolism. The urine of these individuals is characteristic of a sweet-smelling odor similar to that of burnt maple syrup, and that's how the disorder got its name. So affected infants will present rather early in life with poor feeding, lethargy, and seizures, and this needs to be identified quickly, otherwise there are significant concerns metabolically. So it can be treated by management of the diet, but also by avoiding circumstances that increase protein catabolism, such as high fever and dehydration. So that summarizes branched-chain amino acid metabolism, and again, I've focused on that process here based on its clinical relevance.